Hey everyone, this is Pargo Suthar, and today we will discuss other types of graphs, that is Eulerian graph and Hamiltonian graph. So in this session we will discuss what is an Eulerian path, what is an Eulerian circuit, what is a Hamiltonian graph, and what is a Hamiltonian circuit. Okay, so first let us discuss what is an Eulerian path. So a path is known as Eulerian path if every edge of the graph appears exactly once in the path. Fine. Now let us discuss what is a circuit. We know that what is a circuit. So the circuit which contains every edge of the graph exactly once. So that means in a circuit the edge has to be appear only once. Fine. Each and every edge must appear exactly once. So is called an Eulerian circuit. Now what is an Eulerian graph? So a graph which has an Eulerian circuit is known as an Eulerian graph. Fine. So let us discuss examples. So this is the example. Fine. Now this graph has an Eulerian. It is an Eulerian graph as this G contains an Eulerian circuit. So what is that circuit? So let us start from this A, E, B, E, 2, C, E3, D, and E4, and again A. So you can see that we have covered all these edges exactly once. Fine. So it is an Eulerian circuit. Now let us discuss another example. So just consider this graph. Fine. So this G contains an Eulerian path but not Eulerian circuit. Why? This G contains Eulerian path but not Eulerian circuit. So what is that Eulerian path? Just start from this middle vertex. Okay. So E, E7, then B, E1, A, E6, F, E5, E4, D, E3, C, E2 and B. Fine. So we have covered all the edges, but we cannot cover all the edges, plus it cannot be a circuit. Okay, so it is an Eulerian path but not an Eulerian circuit. So let us discuss some of the important theorems. So the first theorem. Now an undirected graph, that means directionless, possesses an Eulerian path if and only if it is connected and has either 0 or 2 vertices of odd degree. Okay, let us discuss second theorem. An undirected graph possesses an Eulerian circuit. In previous it was for Eulerian path. Now this one is for Eulerian circuit. If and only if it is connected and its vertices are all of even degree. Okay. So for Eulerian path it has to be connected and it has either 0 or 2 vertices of odd degree, and for Eulerian circuit it should be connected first and then its all vertices are of even degree. Okay, now let us discuss example. So the question is, which of the following graphs possesses Euler's path or Euler's circuit? So just consider this graph and the second graph. Now see, the first one contains what? A path or a circuit. Now you can see that in graph 1. Now what is the degree of each and every vertex? So here you can see that the degree of this first vertex, that is 2. Here you can see that the degree is 4. Here also you can see that the degree is 4. Here the degree is 2. So that means we can see that this each vertex, it is of even degree. So hence it is an Eulerian circuit. Okay. Now in second example, you can see that this graph 2, the second graph, that is connected and it has exactly 2 vertices of odd degree. And which are they? The first one and this the last one. Okay. They have the degree 1. Fine. So they are 2 vertices of odd degree. So what we can say that it has an Euler's path but not a circuit. Fine. Now let us discuss what is a Hamiltonian path. So a path in a connected graph G, it is a Hamiltonian path if it contains every vertex of G exactly once. In Eulerian path there was for every edge. So now here in Hamiltonian path it is for every vertex. Fine. Now let us discuss what is a Hamiltonian circuit. So a path in a connected graph G, it is a Hamiltonian circuit if it contains every vertex of G exactly once except the first and the last vertex. Why? Because it is a circuit. Fine. So let us discuss example. So just consider this is a good example. So a game invented by Sir William Hamilton in 1859 uses a regular solid dodecahedron whose 20 vertices are labeled with the names of famous cities. Okay. And the player is challenged to travel, the problem name is around the world. So the player is challenged to travel around the world by finding a closed circuit along the edges, which passes through each vertex, that means each and every cities, exactly once. So this is the regular dodecahedron, solid dodecahedron. So here we have total 20 vertices, that means 20 cities. Now a traveler must be able to travel all the cities exactly once and come back to the first city. Fine. So what will be the what will be the Hamiltonian circuit? Just think about it. It is very tricky. So one such Hamiltonian circuit, I will give you the answer, and that is this. Just see, consider, start from this 2. So just start from 2, then go to 3, then 10, then 11, then 12, then come back, okay fine, then 4, then go to 5, then 1, then 6, then 7, then 17, then 16, then 15, then 14, then 13, then 20, then 19, then 18, then 9, then 2, then 9 and 8 and 2. Okay, so this is one such Hamiltonian circuit. So there can be a different circuit. Fine. So this is a good example. Now let us discuss another example. Now you must have come across, or you must have seen this type of figure in your schools that draw such graph without shifting a pen. So that is, what does that mean? So that means we need to cover all the edges. Okay, so it is an Eulerian circuit. So is it an Eulerian circuit? So that means we need to cover all the edges. So you can see that this, see how many, the degree of each vertex is what. So you can see that this degree of each vertex is 5. That is an odd number, but we know the theorem that in Eulerian circuit each and every vertex has to be of even number. So but here we have odd. So that means we cannot draw this type of graph without shifting a pen. Okay, so that is not an Eulerian circuit. Thank you.